General characteristics of actinides. Electronic configuration. The actinides involve the gradual filling of 5f subshell. The electronic configuration of actinium atomic number 89 is radon 6d17s2. Thus, from thorium, the 5f subshell start progressively filled. The general electronic configuration of atoms of actinides in the ground state may be written as radon 5f1 say 14 6d021 7s2. Second one is physical properties. First, melting and boiling point. The melting and boiling point of actinoids are moderately high but are lower than those of the transition element. There is no regular trend of melting point and boiling point of the actinides. Density. It reveals that the element near uranium have very high densities. Americium resembles the corresponding lanthanide. Europium is being less dense than its neighbors. Third one is ionic radii and actinide contraction. The size of actinide ion decrease regularly along the actinide series. जो एक्टिनाइड सीरीज है उसका जो साइज है वो रेगुलरली डिक्रीज होता है. दिस इज बिकॉज ये क्यों होता है? विद द इंक्रीजिंग एटॉमिक नंबर द एक्स्ट्रा चार्ज जो है वो न्यूक्लियस के ऊपर है वो पुअरली स्क्रीन्ड बाय द एफ इलेक्ट्रॉन्स. The steady increase in ionic radii with increase in atomic number is called actinide contraction. A comparison of metal 3 positive ionic radii of actinide with those of the lanthanide reveals that actinide and lanthanides are very similar in size. As a result, their chemical property are also similar. It is interesting to note that there is decrease in atomic radii from thorium to uranium, which may be due to the increase the most stable oxidation state from +4 to +6. Fourth one is the oxidation state. The actinides show a greater range of oxidation state than the lanthanide. Lanthanide से ज़्यादा oxidation states की range actinides दिखाते हैं. The second oxidation state in case of actinide is very rare. Americium positive 2 has electronic configuration 5f7. Actinides show the configuration oxidation state +2, +3, +4, +5 and +6. However, +3 is the most common oxidation state among all the actinoids. Some important conclusion regarding oxidation state. All the actinides have an oxidation state of +3 like lanthanides, but this is not always the most stable oxidation state in actinoids. It is observed that most stable oxidation state of element up to uranium is one involving all the valence electrons. Plutonium shows all the oxidation state from +2 to +7, but most stable oxidation state is plutonium positive 4 +4. Similarly, americium show all the oxidation state from +2 to +6. However, from americium, the most stable oxidation state is +3. For all element after americium, +3 oxidation state is more stable. Third one is +4 oxidation state exists for all element from thorium to berkelium, and it is the most important state for palladium and Np. The actinides, fourth one, the actinides form ionic species. The principal ionic species are M+3, M+4, MO2 positive, MO2 2 negative. The lower oxidation state tend to be ionic while higher one is covalent. The general behavior of compound or ions of different element in the same oxidation state is same except their tendency for oxidation or reduction. Fifth one is the heat of fusion and heat of vaporization. The heat of fusion and vaporization are measured only for a few elements. The heat of vaporization is general decrease from thorium to americium. Sixth one is the color of ion. Actinides ions are generally colored. The color of actinide depend upon the number of 5f electrons. The ions contain number of 5f electron or 7 5f electron. Exactly half filled electrons are colorless accepted. The ions containing 2 to 6 electron in the 5f subshell are colored. The color arises out of electronic transition between the various energy state within the 5f subshell. The color of actinide ion arising from absorption of light depend upon 5f to f or f to d and charge transfer transitions. Seventh one is the formation of complexes. Actinides have greater tendency to form complexes in the comparison to lanthanides. This is because of higher charge and smaller size. फॉर कॉम्प्लेक्स कैसे बनाते हैं कि जब हायर चार्ज और स्मॉलर साइज होगा, जब उनकी टेंडेंसी कॉम्प्लेक्स बनाने की सबसे ज्यादा होगी. दे फॉर्म अ वाइड रेंज ऑफ कॉम्प्लेक्स इन डिफरेंट ऑक्सीडेशन स्टेट्स. Eighth is reactivity. The actinides are electropositive and very reactive metals. The reactivity increase with increase in atomic number. जैसे जैसे atomic number बढ़ेगा वैसे वैसे reactivity बढ़ती जाएगी. The direct reaction of actinides with oxygen, halogen and acids are similar to the lanthanides. They react with hydrogen to form non-stoichiometric hydride with the formula of MH2 and MH3. They readily tarnish in air, forming a coating of oxide, which is protective case of thorium but less for the another elements. These metals react with most known metal, especially when heated. They resist attack of alkalis and are less reactive towards acids. The chemistry of actinides is mainly concentrated on uranium and to a lesser extent on thorium and plutonium. Ninth one is magnetic property. The actinides show magnetic property to lanthanides in terms of magnetic moment with the number of unpaired electrons. It is important to note that the high valence state have been chosen for 5f1, 5f2, 5f3 and 5f4 ions, which show the close similarities. Magnetic moment value for the isoelectronic actinide is lesser than the lanthanide ion. Then comparison of lanthanide and actinide series. Both lanthanide and actinides involve the filling of f orbital. They show close resemblance in some of their property but also differ in many properties. Some similarities between lanthanoid and actinoids are given below. First one is both exhibit oxidation state of +3 predominantly. Second one, in both series f orbital are being progressively filled, यानी कि lanthanide actinoid दोनों में f orbital filled होगा. Third, actinoid and lanthanoid having same number of unpaired electron, दोनों के same number of unpaired electron होंगे. Fourth one is both are electropositive and have high reactivity. Fifth, like lanthanoid contraction, there is actinoid contraction. These contraction are due to poor shielding of 5f and 4f electrons. The sixth one is the nitrates, perchlorates and sulfates of trivalent actinides and lanthanides are soluble, where hydroxide, fluorides and carbonates are insoluble. Seventh one is actinides like lanthanides show ion exchange behavior. Then difference between lanthanoids and actinoids. First, lanthanoids show mainly +3 oxidation state except in a few cases where it is +2 or +4. On the other side, actinides always show higher oxidation state of +4, +5, +6 and +7. Second one is lanthanoids have very large energy gap between 4f and 5d subshell. Their chemistry is fairly similar. Second one is on the other side, actinides due to very small energy gap between 5f and 6d subshell, there is variability in chemistry of elements. Third one is lanthanoid compound are less basic. On the other side, actinoid compounds are more basic. Fourth one, lanthanoids are paramagnetic and their magnetic property are easily explained. On the other side, actinoids are also paramagnetic but their magnetic property cannot be easily explained. Fifth one is lanthanoids have most of their ions are colorless. On the other side, actinoids most of the ions are colored. Sixth one, on the lanthanoid side except promethium they are non-radioactive. On the actinoid side all the actinoids are radioactive. Seventh one, on the lanthanoid side they do not form oxoanion. On the actinoid side they form oxoanion. Eighth one is on the lanthanoid side the tendency to form complex is less. On the actinoid side they have greater tendency to form complexes. Ninth one is on the lanthanide side binding energy of 4f are higher. On the actinoid side binding energy of 5f are lower. Thank you.